So we've been talking about MergeSort. Oh, and just as a reminder, and there was a post up on Slack, the required hackathon is this Saturday. So there's a link for you to sign up. If you have not already signed up, you should sign up right this instant. Take 30 seconds, go sign up. Remember, there's going to be an alternative assignment if you're not able to attend the hackathon, and it probably
Question.
won't be a good one. What's up?
Where's the hackathon taking place?
It is in the computer science department at the school.
Okay.
And if you click on the link, it has all the information about the thing. All right. So again, that is this Saturday. And we announced it a while ago. Let's see. Do that. Then this. Okay, so last time we started talking about MergeSort, and I kind of walked us through the initial breakdown of how MergeSort works. We'll go ahead and do the second half of this guy just as a reminder of what we did last half. Remember, MergeSort requires 2 calls to MergeSort, 2 recursive calls. We ask ourselves the question whether something is trivially sorted. A collection is trivially sorted if it only has 1 element in it. A human being can look at these 4 things and say, oh, those aren't sorted, right? Because we are able to glance at all the different buckets all at the same time and say they're not in order. But a computer program can't necessarily do that. So the mechanism by which MergeSort works is it says, look, if it's a 1 list, there's just 1 thing, I'm going to say that's already sorted. By definition, it's in order because there's only 1 thing. Otherwise, I'm going to make the assumption that I have to put it in order, even if it might already be in order. And that's the merge step piece of this. Okay, so originally, we saw this giant list here and we said, is that trivially sorted? The answer is no, it's not a 1 list. Okay, so what do? We split it in half. We call MergeSort on the left half, and then we call MergeSort on the right half. Well, when we called MergeSort on the left half, it said, is that trivially sorted? Nope, so it called MergeSort on the left, called MergeSort on the right. Said, is this trivially sorted? Nope. Called MergeSort on the left, called MergeSort on the right. Is this trivially sorted? Yes. Is this trivially sorted? Yes. Then it used a merge step to put these 2 things back in order. We'll see that again here in a second when we come over to this side. Then it got to that second right call over here. Is this trivially sorted? No. Call MergeSort on the left, call MergeSort on the right. Is this trivial sorted? Yes, we're done. Is this trivially sorted? Yes, we're done. Then we perform the merge step on that portion of our list. Then we get back to this level and we perform the merge step on this portion of our list, ultimately leaving it with this left half being sorted, 1, 2, 3, 5. Then we finally get to our original second MergeSort call. This guy that's been waiting around for this whole left side to finish. We finally get to our second MergeSort call. So this is going to be that call to MergeSort, and this is where we'll do those things we just talked about again. So we're just repeating what we did at the end of last class as a reminder, because we're going to write some of this today. All right, so we're going to say, is this trivially sorted? It is not. It's not a 1 list. So what do? We call MergeSort on the left and we call MergeSort on the right. Again, this right half MergeSort does not get executed until this guy fully finishes, which we can see is going to have a couple of other MergeSort calls inside of it. All right, so we're calling MergeSort on the left. That's this guy right here. We're going to say, is this trivially sorted? It is not. So we call MergeSort on the left and we call MergeSort on the right. Is this guy trivially sorted? It is. Is this guy trivially sorted? It is. So now we bounce back up and we do the merge step with this guy. And the merge step requires that we create a copy of the array with the same number of buckets. Well, create a new array with the same number of buckets. And we go through this guy. We go through the left half and the right half, picking the winners. Okay, because the idea here is that the left half and the right half should all be sorted in and of themselves. So the left half of this list is sorted. The right half of this list is sorted. So if we go through all the elements of the left half and put them against the elements of the right half and we pick winners, we'll end up with a sorted version. And it'll make more sense when we get up and do it with the 4 element thing here, since there's only one guy in each side here. So we say, which is the smaller value, a 4 or a 13? Well, 4 is our winner. So we'll put a 4 here. Then we increment this. So now we're off the end of the left half. We finished picking all our winners from the left half. So which is the smaller value, any legal element or a 13? 13 wins by default. All right, so we got 4 and 13. Now as a human being, we can see that, oh, we actually haven't done anything here. It was already sorted. It happened to already be sorted. But from a computer's perspective, we went ahead and assumed it may not have been sorted and just did the sorting. Often asking questions like that is faster than checking. All right, so that's kind of where some of the speed of MergeSort comes in. So now I have in this temporary array my sorted version of this portion of my array. The portion of my array I'm looking at here is buckets 4 and 5. All right, because I'm really operating on the entire list all the time. I'm just passing around which portion of the list, maybe the begin bucket and the end bucket that I'm interested in. So I'll pass this entire list and then I'll pass begin as 0, end is 3, for example, and that clues me in that that's the section of this array that I'm interested in dealing with right now. Or in this case, begin and end were 4 and 5. This is the section of that array I'm dealing with. So I've made a temporary array that has buckets 0 and 1 in it. Okay, so even though both of these guys are 2-element arrays, this temporary one is only a 2-element array, so it's only bucket 0 and 1. Where this guy up here is a portion of presumably a larger array that is only a 2-bucket portion, but we don't actually know where those indexes are other than using begin and end. All right, so I have my answer here, so I need to copy them back over into the original array. And remember, arrays are passed by address. So anytime we make a change to the original array, we'll make a change in that address, it will be a permanent change noticed everywhere. All right, so I'm going to go through every element of this guy and copy it back over the elements of this guy. So I'll copy bucket 0 over bucket 4. There's my 4. Bucket 1 over bucket 5. There's my 13. All right, so now I have merged those guys together and I have sorted this portion of the list. And technically this became a 4, this became a 13, this became a 4, this became a 13, even though that's what they already were. All right, so now I'm done with this call to MergeSort. So now I get to my second call to MergeSort. And we say, is this trivially sorted? It's not. It's a 2 list. Is this true? So we call MergeSort on the left, we call MergeSort on the right. Is this trivially sorted? No. Or I'm sorry, yes. Is this trivially sorted? Yes. So now we do our merge step. We create a temporary array that has enough elements in it. But again, this guy's just bucket 0 and 1, even though we're dealing with bucket 6 and 7 here. And then we start going through and we pick our winners. Which is smaller, a 3 or an 8? The 3. Which is smaller, an illegal position or an 8? The 8 wins by default. We copy the values back over. 3 becomes 3, 8 becomes 8. It copies throughout, so we didn't happen to make any changes there, but we will make a change here in a second. All right, so now we finished this call to MergeSort. So this right half is now sorted in and of itself. So now the two calls to merge sort have finished up here. And now I have to merge those guys together. And we'll see that we're going to have to pick some winners here. So we'll see the actual merge algorithm a little bit cleaner here. So what do? I create a temp array that's the same size as my original. We'll empty this guy out. It's going to be our, kind of think of it like our podium. We're going to use it to hold the winners, and then we'll copy them back over. All right. And remember, this is the left half. This is the right half. So our first race is 4 against 3, which is the smaller value. The 3 is the smaller value, so we place that there. Our next race is 4 against 8, which is the smaller value, the 4. Our next race is 13 versus 8, which is the smaller value, 8. And our last race is 13 running solo against nobody. So he's the default winner. So that's a 13. So then what we do is we copy the contents of our temp array back over this section of our array. That's going to give us a 3, a 4, an 8, and a 13. And since we did all that in memory, that would have also had the effect of this 3, 4, 8, 13. All right. So now we have finished our second original call to merge sort. So now what we have is we have our entire array partially sorted. The left half is sorted and the right half is sorted. So now we want to merge those two together to give us a fully sorted array. So what do? That same thing we just did. Create a temporary array. All right. And it just so happens that this array is 0 through 7 and the original is 0 through 7 since we're dealing with the entire array now. All right. So our first race is 1 versus 3. Who wins? The 1 wins. Second race is 2 versus 3. Who wins? The 2 wins. Third race is 3 versus 3. It doesn't matter who we pick. So let's just say we're always asking if this value is less than this, we'll say less than this value. And if it's, so since 3 is not less than 3, we'll pick this 3 to be the winner. Next race is 3 versus 4. Is 3 less than 4? It is, so we'll pick the 3. Next race is 5 versus 4. So we're going to pick the 4. Next race is 5 versus 8. Pick the 5. Next race is no contender because we're off the end of we already placed our last value from the left half. So we have no runner over here and we're going up against the 8. So the 8 wins by default. Similarly, the 13 will win by default. We'll copy those values back over from temp. Let's just do it like it actually happens because these are 2 separate arrays right now. So this will be a 1, a 2, a 3, a 3, a 4, a 5, an 8, and a 13. And that completes our final merge step. And now we see that our array is sorted. Okay. So a lot of moving parts there, but we're actually going to see that the algorithm for this, because it's written recursively, remember we've been talking about recursion, and if you go up here, this explains MergeSort, like one way you could do it. It's a little bit different than the way I explain it, but it's pretty similar. So if I were you, when you go to do your homework, I would go back and watch this portion of the video that has me walk through MergeSort so you understand those steps. We're going to write the first part of this today that splits it into pieces. So let's see, what do I want to do? And then this is actually going to be our homework. All right, so I'm going to make a copy of this guy. And I'm going to jumble these guys back up. There, not sorted anymore. All right, so we're going to have a collection that's going to look like that, for example. And we're going to write this guy initially in the context of our Android application. So we'll go into Android Studio. All right, and I've already created this project for our MergeSort thing in preparation for this, even though we've currently written a our factorial thing in here. So what I'm going to do is we're going to get this working inside of, so we're going to just write standard Java code. Actually, let me think about that. No, I'm going to use the Android interface to do this because I think right now, let me just run this real quick. I just have 2 edit texts and a where is my emulator? All right, yeah, so right now it just looks like this, calculates the factorial. Okay. So we're going to go ahead and strip our interface a little bit here. And we're going to give ourselves a collection of numbers, and we're going to show that in a list view like we did a couple of classes ago. So I'll go to my activity main. I'm going to actually just get rid of all this. So we'll delete those things, leave ourselves our vertical linear layout thing there. All right, then I'm going to go to our legacy thing, and I'm going to choose a list view. And our list view is going to have our initial list of numbers. All right, and we're going to call this guy our list of numbers LV. All right, and let's just get that guy filled up with some stuff right now. And actually, I'm going to do a button above this guy, just so I can kind of say, go, start MergeSort, whatever, however you want to think about it. All right, so that'll be start MergeSort on that guy. But we need to go ahead and fill up this array list with some stuff. Well, we need to remember the way we handle this is we have a list view. Then we create an array list, which we've done before. We fill the array list up with the crap that we want to have in it. And then we use something called an ArrayAdapter to adapt our array list to this list view. All right, so we're going to use this to show our numbers. All right, so let's go ahead and do that. So I'll go back into our main activity. I'll dump these guys. Let me just gut this real quick. So now we're back to just a plain Jane project. All right, and so I'm gonna go ahead and give myself a private list view, and we'll call this, so what do I name it over here? I like to name them the same. It doesn't have to be, but list of numbers LV. List of numbers LV. And then inside here, we'll say this dot list of numbers LV is equal to this dot find view by ID r dot ID dot list of numbers LV. All right, so again, MVC, we've connected this programmatic variable to something that actually lives in our interface. This is how we've linked them. Okay. Now we want to go ahead and we want to also have an array list here. And I'm going to make my array list. I'll make it global here. That'll make life a little easier for us. So this is going to be our array list. And I'm going to do this guy of strings just to keep it simple with our array adapter. Otherwise, we'll have to write a custom array adapter to be able to show the contents of an array list of integers. So I'm going to have an array list of strings, and then whenever we need to turn them into integers, we'll just pull them back out and convert them to an integer real quick. So this will be an array list of strings. We'll call this guy the list of numbers. As strings, we'll remind ourselves that that's what that guy actually is. And we'll say this dot the list of numbers is equal to a new array list of strings. All right, then we want to go ahead and start putting some values in there. And just for the sake of this example, I'm going to fill it up with our identical values to what we have here. So 528. So this dot the list of numbers dot add 5. 2, 8. 3, 13, 5. And 5, 8, 1. All right, so that should be our contents of our array rather than filling it up with random numbers right now. That way we can more easily compare it to our actual example here. Typically, you would have some random numbers that you prove you can sort, but in this case, we want to kind of know our output. All right, so now I have my array list filled up with stuff. So now I need to go ahead and I need to create an array adapter. So array adapter of type string, since that's the one that'll work the easiest for us. We'll call this guy the adapter. And this is a new array adapter of type string built around the list of numbers as strings. I think we also need to give it, don't we need to give it a context? Oh yeah, we need to give it 3 things. We need to give it a context. That's this. Then we need to give it our what is it? Android.r.layout.simple list item 1. So that's the default like simple built-in, I know how to show one element on the screen list item. And then we give it our collection. All right, so to build an array adapter, we need to tell it what's the context. So the context is almost always going to be this particular activity, unless we have a reason to target some activity that's on another screen or something like that. But in this case, we have one screen, so it's going to be this activity. This is the interface view we're going to use to show our stuff, which is just the built-in simple one. And then here, and this guy expects a collection of strings. So that's why I've purposely chosen to have a collection of strings here. rather than a collection of ints. But since Java is a string-based language, we can easily convert things back out to integers and then convert them back to strings. All right, so this is an advantage of Java here rather than having to write a custom array adapter, which wouldn't be that bad. Writing a custom one isn't a big deal, but I just don't want to spend the time on it in here since it's more of an Android interface thingy than a computer science Java thingy. All right, so that's us hooking up our adapter. And if you want to be able to read this a little bit better, I think I can kick it down a line like this. Actually, I'll do it on these guys. Now you can read it all on the screen a little bit better. Remember, Java doesn't care if the stuff is all on one line, your entire program. So you can kick it down like this. All right, so we built our adapter. We built our array list. We built our adapter that adapts that array list for a list view. And then we'll say this dot, what do I call it? List of numbers LV dot set adapter to the adapter. So that'll connect that guy up. All right. So this is our list view. This is us creating our list and filling it. This is us creating the array adapter for that list of items with this interface element in this context. And then this is us putting together the sandwich, saying we want our list view to have his adapter set up as the adapter we just created, which adapts this array of strings to this type of view in this context. All right, so we'll go ahead and run this, and the hope is we get a list view with all of our numbers in it, currently out of order. All right, so there's our list view of all of our numbers, 528, 313, 5, 581. All right, so now what we want to have happen is we want to start calling MergeSort on this list. And when we click Start MergeSort, we want it to take our entire list and start asking those questions that we asked before. And I want to check something here real quick. I think it's the adapter. Yeah. Allow me, for convenience, to make our array adapter global as well. So we'll still initialize it here, but by making it global, as we change this list, we can notify this adapter that we've made a change and ask it to refresh that list view. So it's the adapter that knows how to do that. And I'll show you what I mean by that here in a second. So I've made all those guys variables that are accessible anywhere in the class. That way, when I write my on button click method here in a second, I can change some stuff around in my array adapter and let the list view know things have changed. All right, so now we're going to go ahead and write our public void on MergeSort button clicked. This guy will take a view as a parameter. And now just for the sake of testing here, what I want to go ahead and do is I want to add some more elements to this, and we'll just hard code those in for the second, just so we can see how the change works. All right, so when I click that, I'm actually adding another 8 elements to my array list. Now, I actually think that we won't see a change at first. Here. I'm pretty sure what happens is if we don't notify the adapter that there was a change, what'll happen is that change will not be realized until the next time you interact with the interface. Then you can force it to update. I'll show you this here in a second. So let's just say this is all our MergeSort button clicked currently does. So we'll come back over here. I'm going to let this button know that that is his on click. We'll call this on MergeSort button click thing. So we'll go ahead and run this. All right. So we get that. Now, if I click Start MergeSort, notice we know we've added some more numbers, but nothing's showing up on here. But if I interact with it, oh, I crashed it. I thought it was going to update on its own if I changed it. This is not the way we're doing it anyways. We're going to use the adapter. I'm actually going to run that one more time just to make sure nothing funky happened there. I'll start MergeSort. It added some stuff. Yeah, doesn't like it. Okay, well, it's fine. So we've added some stuff to this. I'm going to go ahead and say this dot the adapter dot what is it? Set. No, is it notify? Notify data set changed. So this is us letting the adapter know that the data set has changed so that it can refresh itself showing that new data set. So you see how it updated now? If I do it again, it'll add more stuff, so on and so forth. Not that this is necessarily what we are going to be doing in this. This is just more of a example of how you can update your adapter. So it's actually the adapter you talk to and you say, look, I've made some changes to my array list. For example, like changes we're going to be making related to MergeSort. I've made changes to my array list. And now what I want to do is I want you to see those changes as they've being made. So you let the adapter know that he's now showing different elements. So go ahead and update his list view. All right. But now what I'm going to do, since we're only writing the first half of this in class today, is in my interface, I'm going to actually create a second list view. So I'm going to create because what I want to do is I want to have a list view that shows the all the different splits, the different portions of the array that we're working on, everything up to that merge step. Go to legacy. I'll go to list view. I'll put this guy, well, actually it doesn't matter. He can be beforehand. And we're going to call this guy the calls to MergeSort LV. All right. And we're going to go ahead and have its height wrap content and have this guy's height wrap content. Actually, let me see last time. It's not the height of the list view. Well, we'll see in a second. I think I might not be able to make it wrap content. I think you needed to put it inside of a linear layout, maybe. You know what? Just to make this easy, let's set this to 200. Set this to 200. We could probably do 400 with them. 350. We'll just make it 300. So if you're using the same device as I'm using, you can just hard code this these sizes in there. I think it actually wants it to be DP. Density independent pixels. All right, so I've made my two list views roughly take up half the screen. All right, and what I want is I want to have this first one show me my individual calls to MergeSort. So this first one here is going to initially have nothing in it, and then we're going to start filling it up with strings, showing the elements of the list that we're currently interested in, just proving those individual calls to MergeSort. All right, but we're going to go ahead and set this guy up. So we're going to actually call this guy. I'm going to right click here on the adapter, and I'm going to say refactor and then rename. And we're going to call this guy the, what do I call it? List of numbers adapter. And notice when I changed it there, it also changed it down here. So if you go up to where it was defined and you highlight that variable and you right click and you say refactor and then rename, it'll change it in all places where you've used it. It's kind of a, where's my refactor? Right here, refactor, rename. It's kind of a handy way of updating the name of a variable name and having it change all the places you use it rather than you having to go hunt for it. All right. So I'm going to go ahead and just create a second copy of all these variables because I'm going to need these guys for my second list view. And what did I call this guy out here? I called it the calls to MergeSort LV. I'll just steal it from there. Calls to MergeSort LV. And this is the list of MergeSort calls. And this is the adapter for that guy. So we'll go ahead and set those up. But initially, my list of calls to MergeSort is going to be empty. We're not going to have anything in there. So I'll say this dot, the list of MergeSort calls is equal to a new array list type string, and we won't put anything in it. So this guy will show the parts of the array list we are working on in MergeSort. And as of right now, we haven't called MergeSort at all, so we haven't done any of these guys. All right, then we're going to go ahead and set up our adapter. So I'm going to do a pretty similar thing to what we did right here. Except the adapter for this guy is our calls to MergeSort adapter. Context is this, same list thing, whatever, but we're going to be using our list of MergeSort calls as our source data. And then we need to go ahead and set up our, get our list view. So we'll say this dot is equal to this dot find view by ID r.id dot the calls to MergeSort list view. And then lastly, we'll say this dot the calls to MergeSort list view dot set adapter to this dot the calls to MergeSort adapter. Right. So this creates an empty collection, creates a list view around that, and adapts that list view for that, or adapts the collection for our list view. Right. So as of right now, we're not going to have anything in there. This guy will still have all the other stuff we had in there. So let's just see that real quick. We should have two different list views now. One of them is going to be empty. The other one will have stuff in it. All right, so here's our empty one up here. Here's our one with stuff in it. Okay. So now what we want to do is we want to start our, when we say start MergeSort, we want this guy to start asking those questions we asked in our example. Is this a one list? If it is, we're ready to do a merge. If it's not, we need to call MergeSort on the left, call MergeSort on the right. So I'll go in here. And I'm going to go ahead and I'm going to write a function here called private void MergeSort. And this guy is going to take a array list of strings as a parameter, as well as an int begin and an int end. This is the portion of that array list that we're currently interested in when working with this MergeSort call. All right. So when we first call our on MergeSort button, we want to call MergeSort on the entire array list. So we'll say this dot MergeSort, and the array list we're passing it is our list of numbers. This dot the list of numbers as strings. And then begin is going to be the very beginning of that guy. And the end, we're going to make the last legal bucket. That is this dot that guy dot size -1. So when we call our MergeSort button, we'll make it our initial single call to MergeSort. We're going to say, I want to sort this list starting at the beginning of it all the way to the end of it. All right, that's what on our MergeSort button will ultimately do. It'll call MergeSort internally. All right, so then inside MergeSort, we need to ask if this list is trivially sorted. Is this list trivially sorted? Well, it's only trivially sorted if begin and end are the same. Right? We go back to our thing here. If I ask if this is sorted, the answer is yes, because begin is 0, end is 0, so it's a one list, therefore it's sorted. So I only want to do stuff in here. I only want to do anything inside MergeSort if it is not trivially sorted. So if begin is not equal to end, if those guys are different values, that means that I do not have a one list. And if I do not have a one list, so this means I do not have a one list. So I need to divide my list in half and call MergeSort on the right and the left. All right. Now, one thing I'm going to do before anything else here, though, is I want to build up a portion of my list to show inside of my list of merge sort calls. So I'm going to write another little function here, public string build string from part of lists. And I'll go ahead and pass it my array list of strings. Pass it begin to end. And I'm just going to create a string S here as the empty string. And I'm going to loop through my list from bucket begin to bucket end, just building up the different values that are in there as a string separated by spaces maybe. That'll just give me a little visual snapshot of the portion of my array list that I'm currently working with. So I'll say for int I is equal to begin, I is less than end. Actually, I want to say less than or equal to end, since we have end including that last bucket. I plus plus, and we'll say S is equal to S concatenated with the list dot get I concatenated with a space. And then we'll return S. So this should just build up like a string that looks kind of like maybe 5283. A string that is a 5 plus a space plus a 2 plus an 8, or a space, then an 8, then a space, then a 3. Just the portion of the array we're looking at. All right, so first thing I'll get here is string current part of array is going to equal to this dot build string from parts of the array. I'll pass it the list, I'll pass it begin, and I'll pass it end. And then what I want to go ahead and do is add that to my list of things. So this dot the list of merge sort calls dot add current part of array. And then I'll say this dot the list of merge sort, the calls to merge sort. Where's my adapter? Oh, it's called the calls. The calls to merge sort adapter dot notify data set changed. That's what, that way it'll update it in there. All right, so initially I'm calling merge sort, passing it my full list, passing it begin, passing it the actual end. So my very first call to merge sort is on the entire list. And then we start breaking it down. All right, so if I go ahead and run this, we should get one thing added there since I don't call it recursively again yet. So when I say merge sort, it's saying I'm sorting this on the entire list, 5, 2, 8, 3, 13, 5, 5, 8, 1. Doing it on the whole rigmarole. Okay. So then the next thing would be calling merge sort on the left half, calling merge sort on the right half. So homework, update the list of merge sort calls to show all of the individual calls we make to merge sort. All right, so in our example here, we should see the first thing is all of it. The second thing is a call to 5283, then a call to 52, then a call to 5, then a call to 2, then a call to 8, then a call to 3, then a call to 13581, then a call to 135, then a call to 13, then a call to 5, then a call to 8, then a call to 1, and then finally we're done. So it should show you that breakdown of all the things. All right. And I'll put in the example output that you should have for this so you know kind of what you're targeting. All right. So we'll do that for Friday. I'll go ahead and push this code up to GitHub. Now you're not actually doing the merge step for Friday. You're not actually sorting. You're just proving all the individual calls to MergeSort. All right. That you're breaking your data up in the right halves. All right. Questions, comments, concerns, bribes. All right. I'll see everybody on Friday. Don't forget to sign up for the hackathon as soon as possible.